Hi all, electrical engineer, Igor Ekimov, is with you. Today we will look at the compact DPS100 power supply from TOOLTOP. The device produces an adjustable direct voltage from 0 to 30 volts. With a current of 5 amperes, a maximum output power of 100 watts. The input is supplied with voltage via a standard DC input, or via Type-C with support for PD/QC protocols. At the same time, the device uses the maximum voltage from the Type-C port. The power supply can operate as a constant voltage source, or as a constant current source. The device is easy to operate and has many protections, but we'll talk about them later. The compact dimensions of the device allow it to be carried in your pocket. The kit includes a convenient carrying box. I constantly review various devices on my channel. Subscribe to the channel so you don't miss these reviews. Special thanks for your likes and reposts. The device is supplied in a rigid package that protects the device during shipment. Open the box. Inside there is a box for storing and carrying the device. Let's get the box. Let's open it. Everything is laid out quite conveniently inside the box. The kit comes with fairly soft cords. On one side there are tulips, on the other there are crocodiles. The length of the cords is about half a meter. There are also detailed instructions in English and Chinese. After the information from this video, you are unlikely to need these instructions. And here lies the device itself. The device does not include an AC power supply. There is a standard DC connector here, to which you can connect most power supplies. There are markings on the body. The input voltage should not exceed 32 volts, but not lower than 5 volts. I will use a 100W power supply, which comes with the FNR-C hydrogen sulfide O2 soldering iron. It just matches the power of this power supply that we are currently studying. I connect the device. The device is controlled by 3 buttons and a 3-position mini joystick, right, left and direct pressing. It is also called a 3-position button. This is all that the device is controlled by. Using Type-C data, you can connect a computer and control the device through it. Here are the tulip outputs, plus, minus. In the middle there is a red LED, indicating that voltage is being supplied to the load. There are holes for ventilation on the front and bottom. For heavy loads, make sure that they are not blocked. Turn on the power by pressing this button. Our device turned on, although no voltage was supplied to the load. The big numbers are the voltage, current and output power. But they are still at 0, since the output is disabled. The screen is quite bright, with a resolution of 320 by 240. The numbers on the screen are clearly visible from different viewing angles. The first thing we need to pay attention to is the input voltage. It appears here. It should be at least 1 volt higher than the output voltage, since this power supply is stepped down. Our voltage is about 20 volts. This is the voltage at the Type-C input. The next step is to adjust the output voltage. Please note that we need the underscore to be in the voltage regulation cell. You can switch between cells using this button. By moving the joystick left and right, we select the discharge that we will adjust. By briefly pressing the joystick, we select this discharge, and we can adjust it. Select the required value and press the joystick again. Please note that the press must be really short. Otherwise, you will be taken to the device settings, which we will talk about later. I set the voltage to 12 volts, since I will connect light bulbs to this voltage. Press the button and switch to the maximum current setting. This function can be used as a DC current limiter, or when the power supply is used specifically as a current source. I leave the maximum value at 5 amps. Next comes setting up the protection. If we adjust the voltage and current during the experiments, we can easily go beyond the load parameters and it can burn out. I limited the maximum load voltage to 14 volts. At this voltage the light bulbs will not burn out yet. But I won't touch the current protection. It remains at the limit of a little more than 5 amperes. Let's see what other parameters are shown to us on the display. This shows the temperature inside the device. It is necessary to ensure that this device does not overheat. Below is the number of the preset we are currently in. Now we are in 0. These presets can be selected and customized. We'll talk about this later. The energy passed through the device is displayed here in milliamp hours or milliwatt hours. The green icon indicates that the device is operating in voltage generation mode. And here the CV is displayed. If the device enters current generation mode, the icon turns orange and CC will be displayed here. If the device turns off by mistake, the icon turns red. And an error code is displayed here. Error codes are in the device passport. And here, in addition to the input voltage, you can see the input current and power consumption at the input. To apply voltage to the output, press the output button. Our LED light came on. The indicator showed voltage, and the message on is displayed. The output is turned on. Let me show you how protection works. Now the output is 12 volts. My protection is set to 14 volts. Here I am adjusting the output voltage. And as a result of an error I set the voltage to 15 volts. And our load was switched off. Here the red icon lights up, and it is displayed that the voltage triggered. If we try to turn on the output again, our protection will be triggered again. To turn on the load now, you need to either reduce the output voltage or increase the protection voltage. It is very convenient that the device has such protection. My stationary laboratory power supply does not have such protection. C returned the output voltage to 12 volts, and we can turn on the power supply. If we hold this button for a long time, we switch to the graphical mode for displaying voltage and current. Also, these values, along with the power, are duplicated at the top. This is sometimes convenient, but I find it more convenient when numbers are displayed. Hold the button again and return to the main screen with numbers. We are in preset 0. If we hold down this key, then we remember the value of this preset, and we can select another preset. For example, I chose the second preset. Click Output. And here we already have the second preset displayed, and our settings are already different. We can change these values. But let me go back to the 0 preset that I already set up. There are 10 of these presets in total. You can adjust the value directly in the table. But it is more convenient to do this if the white screen is selected in the settings. I prefer to adjust them by being directly in them, as I did at the beginning of the video. Here I connected the load. My load is 3 12-volt light bulbs, 20 watts each from the car. Using switches we can step-by-step regulate the load power. Now I have connected 3 light bulbs. The power supply can easily handle this load. The temperature only rose to 41 degrees. Let's reduce the load by connecting only 1 light bulb. Please note that the output voltage has not changed. The device stabilizes the voltage well when the load changes. Let's do another experiment. So I reduced the load current limit to 2 amperes. The output voltage has not changed. But let's connect another lamp. As you can see, the output has dropped, but the output current is limited to 2 amperes. Let's turn on another lamp. The intensity of the lamps decreased further. The voltage became a little more than 2 volts. But the current remained 2 amperes, the same as we set. Please note that the icon here is already orange, and CC is written on it. This is how current stabilization works on this device. Turn off the output. Let's look at the device settings. To do this, hold down the middle joystick button for a long time. The first point is the maximum power limitation. I don't touch her. The next point is the temperature limit. I leave it at 85 degrees. Here you set the initial display on the main screen. Numbers or graphics. I'll leave the numbers. The next thing is that you can initially set the input voltage from the Type-C input, so as not to overload the network power supply if the maximum voltage from it is not needed. Next is the screen brightness. It can be adjusted. Initially it was 80%. I give it 100%. The next item is speaker volume. For me, 20% is comfortable, although initially it was 80%. Next is choosing a language. There is English and Chinese. I leave English. Next is choosing theme colors. I like the black theme better and I'm leaving it. Theme settings apply to the presets and settings page. It does not affect the main screen. Next is the choice of temperature measurement unit. I leave the display in Celsius. Next is the model number, factory reset, device calibration, and exit. My impressions of this compact power supply. Conveniently, it is small in size, and its capabilities are no worse than those of most stationary laboratory power supplies. But keep in mind that the power is limited to 100 watts. Only small numbers on the display are used to display additional parameters. This power supply can be brought to the site in your pocket. The only thing is that we need to know in advance from which source we will connect this device. To connect it to a 220-volt network, you also need to carry a power supply with a cord. You can power it from the car's onboard network, but the output voltage will be below 11 volts, and this must be taken into account. If you have any questions, write in the comments. I left a link to this device in the description. Share the video with those who might be interested in such a device. Subscribe to the channel so you don't miss new videos. Like, and see you in new and old videos.